In the vast expanse of the cosmos, one of the most intriguing and enigmatic phenomena are black holes. These gravitational giants, where not even light can escape, have long fascinated scientists and the public alike. Consider the possibility that each black hole is a bridge to another universe. This fascinating concept suggests that our universe might actually exist inside a black hole belonging to a larger universe. This concept, though seemingly out of a science fiction novel, is a subject of serious scientific discourse. As we dive into this exploration, we'll unravel the theories that suggest our universe might just be a tiny part of something much larger, perhaps inside a black hole in a parent universe.
First of all, talking about the entire universe inside a black hole is a bit extreme, but what I would say is it is possible that, at least according to the traditional general relativistic description of black holes, I'm not going to modify it with modern or more recent conjecture, speculations about firewalls and all that sort of good stuff. So let's just act as though Einstein had the important word on black holes, which may not be the case. But if that's true, then right now it's quite conceivable that the Earth just passed across the edge of a black hole, that we are all now inside of a black hole. Why is that? The edge of a black hole, in Einstein's description, is not some special location in space. It's just an ordinary chunk of space that has the unusual property that once you pass that location, the event horizon, you are no longer able to get out. But you don't have any direct physical reaction to crossing over the event horizon of a black hole.
As we continue our cosmic exploration, let's delve deeper into the startling hypothesis that our universe might exist inside a black hole. This idea, while seemingly far-fetched, is grounded in the principles of physics and astronomy. A black hole is a region in space where the gravitational pull is so intense that nothing, not even light, can escape it. The idea of a universe within a black hole arises from the concept that the singularity at a black hole's center, where density and gravity become infinite, could potentially birth a new universe. Why do scientists consider this plausible? The laws of physics, as we understand them, break down at singularities. This means the usual rules of space and time don't apply, potentially allowing for the birth of a new universe with its own laws and constants. One theory, the black hole Big Bang theory, posits that the matter from a parent universe collapses into a black hole, which then gives rise to a new universe. This theory could provide answers to some of the most profound questions in cosmology. For instance, it could explain the uniformity and flatness of our universe, which are otherwise difficult to reconcile with the Big Bang theory alone. Furthermore, this hypothesis aligns with the concept of cosmic inflation, where the universe expanded exponentially in the first few moments after its birth. The immense gravitational energy of a black hole could provide the necessary conditions for such a rapid expansion. There's also the intriguing possibility that every black hole in our universe could be the birthplace of a new universe. This multiverse concept suggests an endless cycle of universes being born from black holes in other universes, each with its own physical laws and constants. However, this theory is not without its challenges. The nature of black holes and singularities is still not fully understood, and the idea of a universe inside a black hole raises questions about the nature of space, time, and reality itself. While it's a fascinating hypothesis, proving it remains a significant challenge due to the current limits of our technology and understanding. In conclusion, the idea that our universe could exist inside a black hole offers a tantalizing solution to some of the biggest mysteries in cosmology. It's a hypothesis that challenges our perception of reality and invites us to consider the universe in a completely new light.
So right now, everything, as we look around the world, we could all be within a black hole, and we'll only really recognize that later on when we get closer and closer to the center of the black hole, because then, depending on our precise distance from the black hole, different parts of the Earth, different parts of our body will feel a different force. If we are going feet first toward the center of a black hole, our feet will experience a greater pull than our head. Our body will be stretched. Spaghettified is the technical term that we use for this process, until ultimately we're pulled apart into our constituent particles that will all rain down on the singularity, whatever that is, the center of the black hole. We don't really understand what goes on there. So in that sense, we could all be within a black hole right now.
As we journey through the enigmatic world of black holes, let's uncover some fascinating facts about these cosmic wonders. Black holes, regions of space where gravity is so strong that nothing can escape, not even light, are among the universe's most intriguing phenomena. There are different types, including the smallest known as primordial black holes, which can be as tiny as an atom. Despite their mystique, black holes are not mysterious vacuum cleaners of space. They are remnants of collapsed stars with gravity so intense that it warps the fabric of space-time itself. Intriguingly, all black holes are characterized by just three properties: mass, spin, and electric charge. Moreover, it's believed that at the center of nearly every galaxy, including our Milky Way, lies a supermassive black hole, playing a crucial role in the galaxy's formation and evolution. The study of black holes continues to challenge and expand our understanding of the universe.
So I talk about cosmology, what we call the large-scale structure of the universe, so the galaxies and how they formed, how the universe has evolved since the Big Bang, but also black holes. And black holes, and they're really evocative things. I think everyone's heard of these strange things, these totally collapsed stars, from which nothing apparently can escape. But in the past few years, past few decades really, beginning work that Stephen Hawking really began back in the 1970s and many others, we've begun to suspect there's a lot more to them. And they've started forcing us to reassess our understanding of what space and time are. And that's a really weird sentence. You might think, well, space is the arena in which we live and time just ticks, but it really isn't. It looks like, from studying these things, there are building blocks of space and building blocks of time. And so black holes, they're kind of a metaphor in a way, that by studying them, we're beginning to get a deep picture of what our reality actually is. That's a remarkable idea, but it's a beautiful idea that runs through all of science. But it's just a region of space from which even light can't escape. So Stephen Hawking, back in the 70s, calculated that black holes, they glow in the sky, like coals in the sky, and they radiate. And so over time, they lose energy and mass and ultimately disappear over huge timescales. And that's so important. This was the key in trying to understand what happens to the stuff that fell in. When you thought these things existed forever, then you think, well, it's okay, it gets locked up inside, it can never get out, we don't care. But the thing evaporates away, one day it will be gone. So then suddenly you have to be faced with this question, what happened to everything then? If I throw a book into a black hole, is it somehow possible in the far future, if you collect all this so-called Hawking radiation that comes off, is it possible to reconstruct the information in the book? That's been a question, simple question, that's driven this tremendous amount of research for 50 years. And it was pretty much solved in 2019, actually, and 2020. Well, the statement is everything comes out again, all the information comes out. So everything that fell in principle, in the far future, you could reconstruct the information of everything that fell in.
Oftentimes people think about black holes as these gargantuan structures that form from collapsed stars. There's a big one in the center of our Milky Way galaxy, it weighs 4 million times that of the sun. The photograph of a black hole in the galaxy M87, 55 million light years away, billions of times the mass of the sun. But the reality is, anything, if you compress it enough, becomes a black hole. If you take an orange and you squash an orange down sufficiently small, according to Einstein, it becomes a black hole. These things don't have to be gargantuan. The flip side of it is, we also typically have an intuition that black holes are really dense, right? That's usually the way we think about them. But if you make something sufficiently large, regardless of how low its density is, it will also become a black hole. So you can make a black hole out of air by just having enough air. If you have enough air, sufficiently large sphere of air, it would become a black hole too.
In our journey through the cosmos, we've explored the captivating nature of black holes and the idea that our universe may reside within a black hole. This notion not only challenges our understanding of space and time, but also connects us to something larger than ourselves, a cosmic cycle of birth and rebirth, forever expanding our universe's mysteries.